Let's talk about the range of what's visible in the night sky at any given time and talk about circumpolarity. So here you are standing on the Earth, and what's directly overhead, we said, has a declination equal to your latitude. So declination equals latitude. That can be any latitude. I'm going to work with 43 degrees because that's where I'm standing right now, but that could be any latitude you want. And so you can see that's a right angle, so you can see down 90 degrees. So your range down here, what you can see is going to be your declination minus 90 degrees. And the range up here is your declination plus 90 degrees. But for those of us in northern latitudes, you can't go past 90 degrees, so we're going to talk about how to deal with that here. And so you got declination minus 90 degrees. And so for us, at 43 degrees, 43 minus 90 is negative 47 degrees. So that's sort of the theoretical limit of how far south we can see. With local obstructions on the horizon and the thick atmosphere and light pollution and all the kinds of things that go on, it's really, really, really hard to see down to negative 47. I don't think I've ever seen down there from this far north. And we go up this direction, and we would have 43 plus 90 degrees. And if we have 43 plus 90 degrees, that's going to give us 133 degrees. But 133 degrees is not an acceptable value for declination. Declination only runs from minus 90 to plus 90. So we had 90 degrees right here. We had to start counting back down from there. So that's going to be 90 degrees minus the 43 degrees down here, which is going to give you 90 minus 43 is going to give you about plus 47 degrees is what we can see. So everything that is here actually never gets below our horizon. Anything that's this close to the pole will stay above the horizon all the time, and we call that circumpolar. Okay? So you've got that circumpolarity there, and we can say that declination right there, if your declination is, let's just say it this way, if declination is greater than or equal to 90 degrees minus your latitude, then the object is circumpolar. That's plus 47 for us. Again, it's very hard to see all the way to the horizon with hills and trees and buildings and lights and air pollution and all of that stuff. And so that's the absolute limit of what we can do. Let's test this. If we're at the North Pole, then 90 minus 90 is 0, and everything that has a declination above 0 degrees is going to be circumpolar, half the sky. And so at the North Pole, we're going to see the northern half of the sky. At the South Pole, we see the southern half of the sky. And so we're going to see the stars don't rise and set. None of them. There are no stars rising and setting coming above the horizon. They just walk around in a circle like this. If you look at a star near the horizon at the North or South Pole, it's just going to be walking along horizontal to the horizon like that, parallel to it. And so what if we're at the equator? If we're at the equator, 90, our latitude would be 0. 90 minus 0 is 90. And the only circumpolar stars are going to have a declination of negative 90 or positive 90. And so that means only the North Celestial Pole and the South Celestial Pole are circumpolar. There are no circumpolars. You see half the sky at any one time. So that's one thing I want us to keep in mind. You will see half the sky at any one time. You look up, there's half the sky. The other half's hidden below the earth beneath you. And so you can't see through the earth to see the other half. For those of us who aren't at the equator, or who aren't at the North Pole, let's start there. For those of us who aren't at the North Pole, we see new stars down in here. We see new stars coming into view, and the stars that are currently in view disappearing from view. And as we get closer and closer and closer to the North Pole, there are more and more stars become circumpolar, and there are fewer and fewer stars rising and setting. If we go to the equator, we see the entire sky as this thing moves around us here, we see the stars rising and setting. So this is the idea of circumpolarity and the stars that rise and set, and what that looks like depends on where you are on Earth. So thanks everybody. On to the next topic.